Hi all, let's take a look at the Newton's methods problems here in section 4.7. This section's really not too bad, but it takes some getting used to. So once you get the hang of it, you'll think these problems are a piece of cake. Let me make sure that you're in that scenario where you do think it's a piece of cake. Okay, so first problem on here tells us to apply Newton's method to the function f of x at the given initial guess x sub 0, and it wants you to find the first, second, and third refined guess. So f of x in this problem is x squared minus 11. We're trying to find the root of that parabola closest to the initial guess of 3, and it's wanting us to give your answers to 6 decimal places. Okay. So here's what I did. I'll pull this problem up and show you the calculator steps at the same time. So when I'm looking at my calculator with this problem, I'll go ahead and clear this off. We know our original function in this problem that we're trying to find the roots of is x squared minus 11. Newton's method says each successive guess is the original guess or the previous guess minus the function evaluated at the previous guess divided by the derivative evaluated at the previous guess. Well, I need to account for that. So I have the function, here's its simple derivative. So I know that if x equals, or if my original guess is 3, then I need 3 as an answer in on my calculator. So I'll say, let's make sure our calculator thinks 3 is an answer. So it does right now. Now, I'm going to store that value of 3 in for x. So I hit store x. Now I'm going to hit colon, alpha, decimal. Now I type in my Newton's method right here. So I'm going to do x minus the function divided by the derivative. So x minus, and I have a fraction, so I'll do alpha y equals fraction. That's the easiest way to do it. Now, that x is just a given value of x, and our initial value is 3, so it'll be fine. I can just type in x squared minus 11. My denominator here, 2x. All right, so now I have x minus f of x divided by f prime of x. What am I going to do with this equation? Right now, I'm plugging a 3 into it, and this is going to enable me to find my first refined guess here. Notice I hit enter. I get the 3.3 repeating. Now, after you do it one time, it's so simple after that. So all you have to do is store the answer in for x. Now my calculator fortunately thinks the answer is 3.3 repeating. So all I have to do is hit enter again, and it's going to store that answer back into the function and give me my second refined guess. And you can see it's going to be 3.316 repeating. For my third refined guess, you guessed it, just hit enter again, and you'll get the 3.316625. Now, the reason I rounded to 5 decimal places is because Achieve is going to want you to round to 5 decimal places. Now, please remember that first step, you get 3 in as an answer on your calculator by hitting enter, and then you're going to store that answer in for x, and then you're going to hit alpha decimal for colon, then you just type in Newton's method, x minus f of x divided by f prime of x. Now, when I'm looking at the solutions for this problem, I'll say, well, is this all that they want? Absolutely. My first refined guess here is, and they want the answers to 6 decimal places, so I'll say 3.1234563. And then I'm going to have 3.31. Now I'll have 6, and then I need 3 more decimal places. So 6, 6. I'll have to round that last decimal place to 7. And then my last one here, x sub 3 is going to be 3.316625. So I get my values entered in. I'd go to the check answer icon here, check answer, and you got it. Next question here. Now you'll see just to make sure I try to do this video as organized as possible, I went ahead and worked these problems out. So my problem number 2 here gave me f of x is equal to x cubed minus 22, and I have an initial guess of 3. Well, obviously my derivative here in this problem is 3x squared. So Newton's method is going to be telling you that each successive guess is the previous guess minus the original function evaluated at the previous guess divided by the derivative evaluated at the previous guess. Just like last problem, it's wanting us to have 3 in as our original answer. So I'll say 3, enter for my answer here. Now, I'll scroll back up to make sure I'm showing the whole calculator as I do this. I have 3 in as an answer. I'll hit store. I need to store that answer in as X. Now I need to hit alpha decimal for my colon. Now type in Newton's method, this right here, X minus X cubed minus 22 over 3X squared. So X minus the fraction, and I have X raised to the third minus 22, oops, not minus 11, minus 22, all over 3X raised to the second. Typed in the Newton's method, and now, boom, the first refined guess, 2.814815 rounded to 6 decimal places. After that one, you just hit enter 2 more times. There's your second refined guess and your third refined guess. So you just take those 3 answers, which I have them all written here on the paper, and we enter them all in. So we know our first refined guess was the 2.814815. Our second refined guess was the 2.802097. And our third refined guess here was our 2.802039. Now, please notice, with each guess that you have, it's converging on a value. It's changing fewer and fewer decimal places each time. So that does tell us that it is eventually going to converge to the actual root. This is just wanting the first 3 guesses. Okay, we got it. Up next. So 3 brings in a trigonometric function, no big deal. My trig function in this one is the cosine of x minus 8x with an initial guess of x equals, or the initial guess of 1. So I know my derivative here, derivative of cosine is negative sine, derivative of minus 8x is just minus 8. So then Newton's method is going to say, well, it's going to be x minus the function evaluated at the previous guess divided by the derivative evaluated at the previous guess. And again, I'll bring this up to show you how we would do that on the calculator. So I'll say, okay, calculator helping in this part of the problem, I can say this is going to be initial guess is 1. I need to make sure 1 is in as an answer on my calculator. Now I need to store that answer in as X, hit colon, then type in Newton's method. It's X minus the fraction, cosine X minus 8X. So I'll say, now please make sure, please make sure you're in Radian mode. You never want to be in degree mode in a calculus class. So I'll say, okay, making sure that you're in Radian mode now. I'll go ahead and type this in. It's going to be the cosine of X minus 8X. You don't need parentheses for that one. You did for the cosine function. Minus the sine of X. So I need to put negative sine of X. Close out the angle minus 8. So I have my Newton's method entered in gorgeously with the initial guess of 1. It's going to take that initial guess, plug it into the function to get my first refined guess of 0.156283. And then we can say, well, we take that answer, plug it in, you get 0.124103. You take that answer, plug it in, and you get 0.124036 to 6 decimal places. This 6 is going to round the 39 up to a 40, so that's why I have that answer to 6 decimal places. Now we'll say, okay, we'll take this answer in here, and I'll try to lift that up a bit so I can still see both. My x sub 1 was the 0.156283. My second refined guess, x2, is 0.124103. And then finally, x sub 3, we had 0.124040. We'll check that answer. And you see correct. Up next, And again, once you do a few of these problems, they all work pretty much the same. Now in this one, it was a little bit more fun because the function that they gave me, I had to use the product rule when I took the derivative. So notice here try to get the glare out of there, for number 4 here, we had the function 1 minus 5x sine x. So that's a differentiable function times a differentiable product rule was necessary. Okay, obviously derivative of 1 was 0. But then I said derivative of negative 5x is negative 5 times the sine of x. And then plus negative 5x, might as well just put minus 5x, times the derivative of sine x, which is cosine x. Now, we know that Newton's method says that each successive guess is the previous guess minus the function divided by its derivative evaluated that previous guess. Okay, so now I start plugging things in. With the initial guess in the problem, it told me the original guess is 7. So I just get 7 into my calculator as an answer. And now I'll take that answer, store it in for x, colon, type in Newton's method. X minus the fraction, and I know the fraction is going to have the function in my numerator, 1 minus 5x sine x, close out the angle. And in my denominator, it's going to have the derivative, so negative 5 sine of x, close, minus 5x cosine x, and I'll close that out. So I get my Newton's method function entered in. With that initial guess of 7 plugged into it, I get a first refined guess of the 6.258732. Then I need a second and third refined guess. My second goes up to 6.315376. And then I notice it's starting to converge on a root. It's changing less and less each time. The first time it changed 0.75. The second time it's changing about 0.06. Now notice it's changing less than 0.01, and it's changing about 0.0005 units from here to here. So it's converging on a root pretty quickly. Now we'll go ahead and put these first 3 roots in there because that's all Achieve is wanting here. So we already had the original guess of 7. Our first refined guess is 6.258732. Our next value here, 6.315376. And finally, our third refined guess, 6.314862. Check that answer. And Achieve says yes. We go on to number 5. Now, when I looked at number 5, again, it gives me a trig function. What you have to make sure you notice the difference in 4 and 5 here. 4, it explicitly said f of x is equal to that. Well, okay, it doesn't explicitly say that in this case, but you're supposed to remember what Newton's method is. Newton's method is the way to find roots of equations. So it finds when they're equal to 0. So it's saying find out when the sine of x is equal to 0 near the initial guess of 18. Oh, okay, we can do that, but in order to do that, you have to understand that your function that you're trying to find the roots of is just sine of x. It didn't explicitly say it, but clearly that's our function. Sine of x is equal to 0. Derivative of that function is cosine of x. So Newton's method is going to be each successive guess is the previous guess minus the function evaluated at the previous guess divided by the derivative evaluated at the previous guess. And our original guess in this problem was 18, so I get 18 entered in on my calculator. And then I'll say, okay, once I do that, and let me drag this up a little bit so I show the whole calculator. Once I do that, I just say I need to store that answer in for x and hit colon. Now, type in Newton's method, x minus the fraction with a numerator of f of x, which is just the sine of x, and a denominator of f prime of x, which in this case is just the cosine of x. Now, we get that entered in. We have our first refined guess is the 19.137314. Our second refined guess, 18.841341. And third refined guess, 18.84 9556. Again, notice in this problem, with each successive guess, the roots are changing less and less each time, which means it's converging on what the true root is. So I'll say, okay, my first refined guess here was 19.137314. My second refined guess using Newton's method was 18.841341. And then finally, my third refined guess was 18.849556. I check that, and it says correct. Now, your last two just try to show you that Newton's method doesn't always have to implicitly refer to a function. You can create a function to represent what you're trying to do in the problem. So in this one, it's asking me to use Newton's method to think about how to simplify 12 to the 1/3 power. So all I need to do is think about this as, well, I know that my x term in this problem is 12 to the 1/3. That's what I'm trying to solve. So Newton's method only works if you have a function set equal to 0 that has a non-constant derivative, okay? So in other words, I don't want my original function to just be a wimpy linear. I can get rid of that by just saying, well, I can also get rid of this 1/3 power by cubing both sides. The solution to this is the exact same thing as the solution to when x cubed is equal to 12. Now, it's wanting the solution near 2, so that was given in the problem. The x sub 0 was 2. But now, I'll go ahead and say, well, then my function here in this case, I can't call x cubed equals 12 my function because Newton's method finds roots. It doesn't find when functions are explicitly equal to 12. So he said, well, all you have to do is move the 12 over to the left-hand side, and you would have x cubed minus 12. And now we know we can find when that equals 0 by Newton's method. I take the derivative to get my 3x squared. The Newton's method is going to be the successive guess is the previous guess minus the function evaluated at the previous guess divided by the derivative evaluated at the previous guess. I bring in the calculator here to help out with that, and I can say, well, my initial guess in this problem according to the website was 2, so I get that entered in. And then I can say, okay, now I store that in for x, hit colon, and then I'll say x minus the fraction, and it is always, always, always f of x, which is x cubed minus 12 in this problem, divided by 3x squared. And you'll see that my first refined guess was 2.3 repeating. Then I had the 2.290249. And then finally, the third refined guess was 2.289429. Now, again, this problem is just wanting me to put those first 3 refined guesses there. So I'll do that to 5 decimal places this time. So I need to be careful. Switched it up on me a bit there. So 2.12345 x sub 2 is going to be 2.29025 rounded to 5 decimal places. And then x sub 3 is going to be 2.28943 rounded to 5 decimal places. I checked that answer, and absolutely. The last question, exact same thing. And hopefully you're not going to do it the cheap way and just say, hey, cool, they just want me to evaluate 11 to the 1/3 power. So all I have to do is go in here and say, hey, 11 raised to the 1/3 power. Woohoo, I'm done. Well, please don't do it that way. That's cheap, 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 cheap. These problems are easy enough without doing it that cheap way. So using Newton's method to get to that, you could say, well, all right, we know that x needs to equal x needs to equal 11 to the 1/3 power. Very similar to the problem we just did. I need to solve for that by cubing both sides and say, well, x cubed is equal to 11. So f of x needs to be the function x cubed minus 11. We'll say f prime of x, yet again, is 3x squared. So I put in my Newton's method where each successive guess is the previous guess minus the function evaluated previous guess divided by the derivative evaluated previous guess. Now, what they did not do in this problem is state what the initial guess would be. That's why they can't ask you what x1, x2, and x3 are, because they're going to differ depending upon what your initial guess is. Now, when I thought about what the initial guess should be for this, the cube root of 11, well, you know the cube root of 8 is 2. The cube root of 27 would be 3. I know 11 is a lot closer to 8 than it is 27, so this answer is a lot closer to 2 than it is 3, just using logic. Okay, now, and that's assuming we hadn't already done this as well. Now, if I put that 2 into my calculator, 2 isn't as an answer. Now I store that answer in as the variable x, then I type in Newton's method, x minus the fraction, x cubed minus 11 divided by 3x to the second. We get our first refined guess here. You see where I got the 2.25. Now, in this problem, it was wanting me to do as many, it didn't just say x1, x2, x3. It's wanting me to do as many as necessary to get 6 decimal place accuracy. So I have to find, obviously, the first refined guess, and I don't have any decimal place accuracy at that point. By the time you do the second refined guess and get the 2.2242798, you can see, well, you have at least one decimal place accuracy at the 2.2 repeated, but then you're not certain about anything after that. So I keep going. I get the third refined guess, the 2.223980131. And at this point, between the second refined guess and the third refined guess, I would be guaranteed 2 decimal place accuracy because they repeated up to 2 decimal places. I had the 2.22 in both problems, but then after that it varied. So I keep going. I need 6 decimal place accuracy, and I'm only guaranteed decimal place accuracy if the next guess agrees with the previous guess. Well, notice by the time we get to the fourth guess, it's almost identical to the third guess. And it's certainly identical to as many decimal places as we need. So the third refined guess was 2.223980131. My fourth refined guess is that exact same number on out to after the 8, it goes 0091. Well, that's no need to worry about that because the 6 decimal places, I know it's going to be 2.223980. And then it doesn't matter whether the next digit is 0 or 1, that's going to be 80 anyway. And so now I would just go in here and say, well, they agree to 6 decimal places by the time I get out to my fourth refined guess. So I'd say 2.223980 was my answer. I checked that answer and it says correct. So hopefully you agree with me. Once you get the gist of this section and you get the calculator buttons down. That's why I wanted to make sure I showed you how I'm doing these on the calculator, but this section is not bad at all. It's pretty quick. All right, guys, let me know if you have any questions. I'll be glad to help.